Hi friends, today we are going to discuss about the special purpose PN junction diode. We are going to discuss about the special purpose PN junction diode. In the one of the special purpose PN junction diode is Zener diode. So we are going to discuss about Zener diode today. Actually, this Zener diode is fabricated by or invented by the scientist Zener. Okay, this is name of the scientist, so because of that his name Zener diode. So it is fabricated by the scientist or is invented by the scientist Zener. That's why its name is Zener diode. Okay, and this Zener diode is operated in reverse bias in the breakdown region. It is operated in reverse bias in the breakdown region. And one of the main use of the Zener diode is it is used as voltage regulator. It is used as voltage regulator. That is one of the main use of Zener diode. It is used as voltage regulator. So now we are going to discuss how this Zener diode is fabricating and how it is working. That we are going to discuss now. Okay, for getting a Zener diode, we are heavily doping the P and N side of a PN junction. So we are heavily doping the P and N side of a PN junction. Then we get a Zener diode. Here P side and N side is heavily doped. Because of that, the thickness of the depletion region is decreases and thickness is in the order of 10 raised to minus 6 meter. And due to that, the electric field between the depletion layer is very high. The electric field between the depletion layer is very high. Okay, so that is one of the things. Okay, so N side and P side is heavily doped. Okay, so thickness of the depletion layer is very thin and the electric field in the junction is very high, extremely very high, is the range of 5 into 10 raised to 6 volt per meter. Okay, and this is a symbol of a Zener diode. This is a symbol of a Zener diode. This Zener diode is represented by like this. This is a symbol of a Zener diode. So now we are going to study the IV characteristics of a Zener diode. Now we are going to study the IV characteristics of Zener diode. As I told, the Zener diode is working in a reverse bias condition. So this is a IV characteristics of a Zener diode. From this found that when the reverse voltage increases, we can see that there will be an increase in current. When reverse voltage increases, we can see that there will be a small increasing current. When a voltage reaches a particular value, we can see that there will be sharp increase of current. Here we are increasing the reverse voltage of a Zener diode. We can see there will be an increasing the current. When a reverse voltage reaches to a particular voltage, we can see that there will be sharp increase of current. So this voltage is called breakdown voltage. This voltage is called breakdown voltage. Is also called Zener voltage. This is called Zener voltage. When the applied voltage V is equal to a particular value of voltage or reverse voltage, we can see that there will be sharp increase of current. Okay, so that voltage is called breakdown voltage or is also called Zener voltage. And again we are after the breakdown voltage, again we are increasing the reverse voltage. Okay, insignificantly we can see there is an increasing current. There will be increasing current we can see. Otherwise, one of the important things related to Zener diode is the Zener voltage never vary with the current flow through the Zener diode. That is one of the important things. In the case of Zener diode, if current is increases, the Zener current is increases, there is no change in the Zener voltage. The Zener diode have a unique feature that the Zener voltage does not vary with the current. Okay, the Zener diode have a unique feature that the Zener voltage is not vary with the current. That means Zener voltage is independent of current flow through it. Because of this reason, we are using Zener diode as a voltage regulator. Because of this reason, we are using Zener diode as a voltage regulation. Okay, now we are going to discuss about how the current is increases in the breakdown region. Now we are going to discuss how the current is increases in the breakdown region. Okay, here we are increasing the reverse bias voltage. Here we are increasing reverse voltage, isn't it? We are increasing reverse voltage. So the current is increases for a particular voltage. We can see that there will be a sharp increase of current. Now we are going to discuss about how the current is increases in the breakdown voltage. We are going to discuss how the current is increases in the breakdown voltage. So in the diagram it is seen that when reverse voltage is increases, the current is increasing. When a reverse voltage reaches particular value of voltage, we can see that there will be a sharp increase of current. We call it as that voltage, we call it as the breakdown voltage, is also known as Zener voltage. Okay, now we are going to discuss at that voltage how the current is increases sharply. Okay, so actually know that the reverse current is due to the flow of minority carrier. Reverse current is due to the flow of minority carrier. The flow of electron from P region to N region and the hole from N region to the P region. Okay, as the reverse voltage is increases, the electric field in the junction becomes significantly increases. Okay, when the reverse voltage is increases, the electric field in the junction is significantly increases. When the reverse bias voltage is equal to the breakdown voltage, when V is equal to Vz, say Vz is called breakdown voltage or Zener voltage, when the reverse voltage, applied voltage is equal to the Zener voltage, the electric field is high enough to pull electron from P region to N region. Okay, when the reverse voltage is increases, when the reverse applied voltage is equal to the Zener voltage, the electric field in the depletion region is high enough to pull an electron from P region to N region. That's why we can see a sharp increase of current at breakdown voltage. Okay, clear? So that is the reason for getting a sharp increase of current at breakdown voltage.